This waveform is actually from right off the cell, and it's a ×10 probe there on channel 1. I just wanted you to have a look at the waveform. I had it spiraling a minute ago. Yeah, look at that. Just thought it looked cool. This is the 9XB. I've just been playing with it. I finally figured out how to hook my scope up to it without blowing anything up. So, and the way I did that is, you can see it's not making a whole lot of gas, but it doesn't make as much gas when I use this isolation transformer. But I have to have it isolated in order to put my probes on it, or it'll short out to the scope, and that wouldn't be good. So, but anyway, I just wanted to kind of see that. It's pretty cool. It's on 1 volt per division at ×10, so 1, 2, 3, 4, 5, 6. So 6 times 6, okay, so that's like 60 volts. Maybe change the frequency a little bit. This is kind of interesting too. You can see at the top of it, when it comes down at the off time, there's a pulse down there. I don't know if you see it or not. But down here, it just makes that ticker. It just bounces it back. And it's at low voltage, right? That's the very next thing, you know. But even if I turn it up, and this is a 20 turn potentiometer that I have on here. And you can see it'll, you can control the way, but those pulses are going to, according to that meter there, that meter goes to 150 volts. Okay. Maybe it's the analog portion of it, but, and you can get kind of crazy, like, depending on, see, and a higher frequency, it stays a little bit more steady, depending on where you're at the frequency. Now, in higher frequencies like this, it's steady. Well, you can see it bouncing a little bit. The light isn't really flashing like this. So even at the higher frequency, if you want to be able to see it, that's why I use the electron extraction here. And you can watch what the pulse does. Even though the light's not doing anything, you can see it here. It's kind of interesting, because there's all kinds of different patterns that it does. that right there and see what it looks like up here. That's at the cell. So